Okay, I will be making this video um, of examples of differential equations, separable differential equations. The first example I want to do is y prime equals x squared over y squared. This looks kind of like the one we did in class. So first, before we do this, we write it as dy by dx equals x squared over y squared. And now we separate the y's and the x's. So when you move the y squared over to the other side, you get y squared dy, and the other side you have x squared dx. I'm sorry. Now, so what we need to do here is integrate y squared with respect to y and integrate x squared with respect to x. This gives you y cubed over 3 equals x cubed over 3 plus this integration constant. I'll just call it c1. Now multiply by 3 in solving for y cubed for y, so you get y cubed equals, multiply this by 3, this by 3, this by 3. This is just another constant. Okay, so when you do that, this will give you x cubed plus another arbitrary constant. Solving for y, you get y equals the cube root of x cubed plus c, and that's the final answer. Okay, you can check that this is the final answer by taking the derivative of y and comparing it to y squared, x squared over y squared. They should be equal. Okay, the next example I like to do is an initial value problem. Y prime equals x squared over y squared, where y of 0 equals 2. This is called an initial value problem. So the way to solve this initial value problem is first solve the differential equation. Solve this to get y equals the cube root of x cubed plus c. This is just the same problem like we had here. So you just solve that. Now, the additional work we need to do is, since y of 0 equals 2, we're going to stick 0 in for x and set it to 2. So that will be cube root of 0 cubed plus c equals 2, which gives you cube root of c equals 2, and that gives you c equals 2 cubed, which is 8. Therefore, the solution to this initial value problem is y equals the cube root of x cubed plus 8. It's a specific curve, specific solution. Okay, because it's an initial value problem. The main idea is, when solving this differential equation, by the way, this is not the same thing as, this is not equal to cube root of x cubed plus cube root of c. It's not the same. So that's not the same thing as that. That's the first thing. And the second thing I want to mention here is that when solving this differential equation, we found a bunch of curves. When c is different, then we have different curve. So I don't know what the curves look like. So for different values of c, we get different values of different curves. Now what this is telling us in this example is, of those different curves, pick the one with y of 0 equal to 2. Pick the one that passes through the point 0, comma 2. When x is 0, y is 2. And this is the one. This is the curve that passes through the point 0, 2, among other curves that could be solutions to this differential equation. Okay? So when you're solving for initial value problem, solve it as if you're solving this just differential equation like this guy here, then use the initial value condition to find the specific c value. C equals 8 is not really the answer. That's a step towards the answer. The answer is this function. It's a function. Okay, let's do another example. I have dy by dx equals natural log of x over x times y. This is separable. Actually, I'm going to add an initial value condition. This is separable. So to separate this, you have y dy equals natural log of x over x dx. So we're going to integrate y and integrate natural log of x over x dx. Integral of y is y squared over 2. Integral of natural log of x, let me see if I can quickly point out how you would integrate natural log of x over x dx. This is a u sub problem. U is natural log of x. This gives you du equals 1 over x dx. So if you put this u in, this comes out as u du, which is u squared over 2 plus c, which is natural log of x, that's the u, squared over 2 plus c. So that's what you get here, okay, on the right side. So let's record that here. Natural log of x, quantity squared over 2 plus c. Just like what we did earlier, we're going to solve for y. So y squared is multiply everything by 2. Let's put c1 here. So I'm going to multiply everything by 2 to get natural log of x quantity squared plus 2c, which is another arbitrary constant. So solving for y, solving for y, we're going to take the square root, but this time it's plus or minus the square root of natural log of x quantity squared plus c. That's the solution. So this is the solution to the dE. This is the solution to the differential equation, to this differential equation, okay? If we didn't have this initial value problem, initial value condition, we would have just stopped here, and that would be the solution. We box that. Remember the plus or minus because this is even. Earlier we had an odd exponent, so we're going to take the cube root of. When you take the cube root or the fifth root, you don't do plus or minus. When you're doing even, if it was to the power of 4, you need to do fourth root plus or minus of fourth root, okay? Now that we have this, let's finish this problem, okay? Let's see if we can find c given this, okay? So I'm going to stick 1 in for x and then set it to 2, okay? So plus or minus, so y of 1 is plus or minus the square root of natural log of 1 to the power of 2 plus c. We're going to want this to equal 2, okay? Now the negative is never going to equal 2. So this initial value condition picks out one of the two. Picks out the plus because this is positive 2. Okay, if it was negative 2 or a negative number, we would have picked the negative, okay? As such, I'm going to do the square root of natural log of 1 squared plus c. We all know natural log of 1 is 0. Okay? So this gives you that c, square root of c equals 2. This gives you c is 4. So your solution now is y equals, now the positive square root, because we've already picked the positive one, of natural log of x quantity squared plus 4. And this is the solution to our initial value problem. Okay, to recap, I have dy by dx equals natural log of x over xy, and with this initial value condition, I will ignore the initial value condition and solve the differential equation first. Once I solve that, then you use the initial value condition to find c. And in this case, when you have a plus or minus, then the initial value condition tells you which one to pick. Okay, the next example is y squared y prime equals x plus 1. So we will write it in dy by dx form. Xy squared dy over dx equals x plus 1. And to separate this, we have y squared dy equals x plus 1 over x dx. So I move this over to that side, and then the dx also. So integrate y squared dy, integrate x plus 1 over x dx. Okay, this is not a proper rational expression, so we're gonna have to break the fraction. Okay, it is 1 plus 1 over x dx. So it's x over x plus 1 over x. So that gives you 1 plus 1 over x. And this one is y squared dy, integrate y cubed over 3 equals integral of 1 is x, integral of 1 over x is natural log of absolute value of x plus c. Okay, once again we're going to try to solve for y. So y cubed equals 3x plus 3 natural log of absolute value of x plus another arbitrary constant. Take the cube root, so you get y equals the cube root of 3x plus 3 natural log of absolute value of x plus c, and that would be your final answer. Okay, I will do 2 more examples real quick and we'll finish. Okay, the next example is y prime equals 2y. Okay, this was the one that we had in class, y prime equals y, or y prime equals a constant multiple of y. This is separable. Dy by dx equals 2y. This is like the population growth kind of problem. So dy over y equals 2 dx. Integrate 1 over y dy. Integrate 2 dx. Integral of 1 over y is natural log of absolute value of y. Integral of 2 is 2x plus some constant. Okay, I want you to pay attention here. I have 1 over y, so its integral is not just natural log of y, it's absolute value, natural log of absolute value of y. Now here we're going to solve for y by moving this into an exponential form. Just to remind you quickly, the log of a base b equals c is the same thing as b to the power of c equals a. This is the log and exponential form you learned in your algebra class. In this case, I have natural log. Natural log is simply a lazy way of writing log to the base e. So the base is e here. So we're going to change this to exponential form, which means e to the power of that expression equals y. Okay? So absolute value of y is e to the power of 2x plus c1. Or absolute value of y equals e to the power of 2x times e to the power of c1. This is another arbitrary constant, but positive arbitrary constant. So absolute value of y is some constant times e to the power of 2x. This is positive, but when you're solving for y and the absolute value equals that, then y equals plus or minus this constant times e to the power of 2x. The nice thing about this is that this is another arbitrary constant. Any constant this time. It can be positive, it can be negative. So I will replace that by a constant, and that will give me y equals c e to the power of 2x, and I have the solution. Okay, and you may notice that when I had y prime equals y, I got y equals c e to the x in the example we had in class. And this is exactly how you solve that differential equation. And so that's the only solution you have. Okay? And finally, I want to do one more initial value problem. Okay, one more initial value problem. I believe it's example 6. And I'll give you the quiz right after this. dy by dt equals 2t over y, and y at 0 equals negative 2. This is similar to what I did just a few examples ago. Let's separate these. dy times y dy equals 2t dt. Okay, I just moved y over and the differential dt over to the other side. Integrate y dy equals integral of 2t dt. This gives you y squared over 2 equals the integral of 2t is t squared plus c. Let's call it c1. Multiply by 2. You get 2t squared plus another arbitrary constant. Take the square root. This gives you the square root of plus or minus, okay? When you take the square root, when you're solving for y, 2t squared plus c. And that would have been the solution if it was just the differential equation and no initial condition. Now, we want y at 0 to equal negative 2. So we're going to put 0 in for t. So I have plus or minus the square root of 2 times 0 quantity squared plus c equals negative 2. Now, the positive square root will never equal negative 2. So we're forced to pick this minus because of that. So we're going to pick the minus, okay? So minus of the square root of, 0 squared is 0. So c equals minus 2. This means that c equals 4. Move the, cancel the minuses and square. So the solution now is y equals minus, let me change pencil. Y equals minus the square root of 2t squared plus c, plus 4. And that is my solution to this differential equation, to this initial value problem. All right, this is, I hope it's not a long video. The quiz that I want to give you is this. Send me an email with the number of examples done in this video. Okay, send me an email with the number of examples that's done in this video. Okay, this is just to check that you watch the video. Have a good break. I will see you when we come back on Monday.